Space Station Freedom, the next step in our continuing effort to explore beyond Earth's boundaries. As we establish a permanent presence in space, new medical challenges will have to be met. With longer missions, larger crews, and the complexities of a medical rescue, the health of Freedom's international crew will be essential for the success of this program. The Crew Healthcare System, or CHECS, is currently being designed and developed primarily at NASA's Johnson Space Center. Distributed throughout the space station, this system will provide the total spectrum of crew health care with 3 distinct but interconnected components: the Exercise Countermeasures Facility, the Environmental Health System, and the Health Maintenance Facility. Air and water, 2 of the most important elements for human survival, on Earth as well as in space. Space Station Freedom will provide crew members with the opportunity to live and work in space for extended periods of time. But how will we ensure the quality of the environment there? How will air and water be kept clean for human consumption now and 30 years from now? These are some of the questions that the Environmental Health System, or EHS, is seeking to answer. Here to explain more on EHS is Dane Russo, PhD, Project Manager of the Environmental Health System.
A unique and versatile concept, the Space Station Freedom will determine what we do in space and how we do it. Its diversity is reflected in its design, which includes pressurized living quarters and laboratories. Maintenance of a safe and habitable environment will be a significant challenge. Space Station's air and water will be recycled in a closed-loop environmental control system. In such a system, all of the elements of the internal environment are linked together. EHS scientists and engineers are working together to develop new techniques for monitoring contaminants in the internal environment, thus working together to help make the Space Station Freedom a safe place to live and work. The laboratory module will provide the space station with facilities for life sciences and materials processing, research, development, and testing. These types of operations, while important for the commercial and scientific success of the station, carry with them the inherent risk of contamination of the space station's internal environment. A chemical spill or leak, or even the common flu virus, could present a potential hazard for space station crew members. Appropriate crew and ground response will require the capability to monitor, detect, and identify space station internal contaminants.
One area of concern is water quality. On shuttle flights, water systems are serviced after every flight. The goal for Freedom is to minimize resupply needs through water recycling. Limited Earth-based experience with water reclamation means that new water quality standards will have to be established for Freedom. The EHS water quality subsystem will set these standards and provide instrumentation for monitoring the quality of Freedom's water. An experiment being examined is the efficiency of iodine for controlling biofilm formation. Biofilm is a combination of microorganisms and their extracellular products that can build up on the inside of water systems and decrease the effectiveness of disinfectants. In this experiment, Untreated and iodinated water is recirculated, with samples taken for analysis of biofilm accumulation. Preliminary results have shown that iodine disinfects the water effectively and significantly retards biofilm growth. Microbiology is another EHS subsystem. Many factors, including in-flight crew exchanges and long tours of crew duty, increase the possible risk of infectious disease and contribute to the need for on-board microbial analysis. Methods to identify microbial contaminants must be developed which are compatible with Freedom's size and weight constraints. One instrument, the Vitec Automated Microbiology System, has been miniaturized for use on the space station. The Vitec system utilizes the same technology used in many hospitals for the purpose of identifying bacteria and determining appropriate medical treatment. It can help determine the cause of an infectious disease or identify a microorganism involved in environmental contamination by matching patterns of known microorganisms against those produced by the specimen. The EHS toxicology subsystem is developing a suite of instrumentation for the detection of chemical and particulate contamination in the atmosphere of Space Station Freedom. The goal of this subsystem is to make these units operate independently and notify the crew only if there is a problem. These instruments will monitor the air for possible contaminants, giving general analysis immediately and in-depth information within an hour. Research in the field of radiation is another area of study under EHS. A group of instruments, including the current thermal luminescent dosimeters, or TLDs, will be used to assess the biological impact of radiation. Until recently, the technology used, the TLDs, measured only the average dosage acquired during flight. A new EHS instrument, the Charged Particle Directional Spectrometer, consists of sensors that electronically register the quality or type of radiation as it occurs. Charged particles enter the spectrometer. Depending on the level of penetration through the sensors, scientists can determine the mass, charge, and velocity of the particle. This understanding will provide the necessary groundwork for future long-duration missions as we continue our exploration of the solar system.
It's because of NASA's concern about maintaining a safe crew environment that we have begun development of the Space Station Environmental Health System. The EHS will provide the program with two essential products: a suite of flight hardware for monitoring the space station's internal environment, and a network of ground support personnel to assist with environmental planning and to help make environmental health assessments once the station becomes operational.
As an integral part of the crew healthcare system, EHS, the Environmental Health System, will provide essential technology for maintaining a healthy environment on Space Station Freedom.